can add the displacements by thinking that if you take an object and displace it by this distance and this direction, and then after that we displace it by another distance in another direction, then adding these two vectors gives this we can think of the addition as just joining the starting to the end point. Okay, so that's adding those two vectors, the two yellow vectors. Now for velocity, we could think of say tossing a ball into a river, and in the river, let's say the river is flowing this way, and a boy tosses the ball into the river in this direction. Okay, now we could imagine that the combined effect can be obtained by completing a parallelogram with the two vectors as the sides. So this becomes a parallelogram. Okay, the opposite sides are parallel and these opposite sides are parallel. Alright, and we think of the combined effect as the diagonal. Alright, so it's somewhere in between the two vectors, but more precisely, very precisely in fact, it is exactly along the line of this diagonal, and it will have exactly this length, assuming that we draw the starting the two original velocities to scale, all right, in a diagram using a pencil and a ruler. Then we can actually draw this diagonal and use our ruler to measure its length, and from the scale we can work out what the combined velocity is. All right. So now let me give this some names. Okay. Let me call this, say the two starting velocities are A and B. Okay, so I'll call this A and B as well. That's A, that's B. Okay, and the final velocity is, say, C cap. C cap. So it looks like there are two ways of adding vectors. But actually, those two ways will work for both displacement and velocity. Now let's have a look at this displacement example. Now, can I also use this parallelogram method for the displacement instead of using the triangle for the displacement? Let's think about this. Right, so actually we can. Now to see how it works, the idea is to imagine that the vectors are arrows that you can move around. So instead of drawing the vectors A and B in the original way, I can draw it this way. Okay, now I have the B here instead and the A here. Now what does this mean? It means that I'm going to pretend that the two arrows are actual objects that I can move around. So it's free to move this around. The only thing is that I have to keep the directions unchanged. So this B here is this B that I moved down here, but I must keep the direction always pointing in the same direction. So likewise for A, I must keep this arrow A pointing in the same direction, but I can move it any way I like. So originally I have the head touching the head of A, touching the tail of B. Now I move them around. I just take them apart and move them around so that the tail of B touches the tail of A. So that's the tail, that's the head. Okay. Now if I then imagine using this idea of a parallelogram to find the combined displacement for A and B, how will I do it here? Okay, the way I can do it is to think of A and B as the sides of a parallelogram, and I can complete the parallelogram by drawing the other two, the two parallel sides. So those are the two parallel sides, and then according to the idea of using parallelogram, the combined results, the resultant would be just the diagonal. Okay, so this result would be the C arrow. Now if you look at this result and this result, these two lines are of exactly the same length and pointing in exactly the right direction, the same direction. Now how can we be sure? Right, quite simply because this side of the parallelogram is not only parallel, meaning in the same direction as B, but also of the same length. Okay, so actually it means that this side is also that's the vector B. So this side here is also the vector B, which is the same as that. If you now look at this triangle and this triangle, therefore they are exactly the same triangles. Alright, these two sides A and B are the same as these two sides, meaning that these two sides have the same length and direction as those two sides, so that the angles here and here are equal, and therefore this angle is the same as this angle, and therefore this angle is the same as this angle. So therefore those two triangles are exactly congruent, and so therefore this vector here and this vector here has exactly the same length. So in this way we can see that the way of using a triangle or using a parallelogram give exactly the same answer. So let me write down this result. I have a result here, okay, which says that if I call one the triangle, right, one of them is called the triangle law of addition. I'll call that number one. So this is number one. This is the number one method. And number two method, all right, number two doesn't mean it's less good. It's just label. So the number two method is called the, it's called the parallelogram, right, law of addition. So now we have two laws of adding vectors and they give the same answer, and you can use either one depending on which one is more convenient.